What's going on, guys? My name is Cheddar780, and today we're going to be doing a bit of a different video. I usually do a lot of gaming stuff, a lot of, streaming and stuff of that nature, but we're going to do something a little bit different today. We're going to talk about something controversial. Nothing that's going to hurt your feelings, but it may make you think a little bit. I'm not trying to put anyone down or, make any group feel bad. I'm just trying to ask a few questions here. So, we're going to be talking about flat Earth and round Earth. In case you don't know, I believe the Earth is round because it's very provably round. But I was just wondering. I've been watching a few videos, and flat earthers are very aggressive with their points, but there's never anything to really go off of. Like I can't like draw a flat Earth, or else they're gonna tell me it's wrong. So I wanted to compile some questions to ask you guys. Anyone that is not a flat earther or a flat earther, feel free to say whatever you want in the comments, and then tell me what you think. If you're a round earther or a flat earther, I suppose, no insults. We're not insulting people here, okay? I won't tolerate that. I won't hear you out if you're just going to insult. I'm just asking questions. Simple questions that, people ask round earthers, and they've had to prove correct or, explain why things do what they do. So I'm asking the same of flat earthers. I just want to know what you guys think so we can come up with a very common consensus as to what you believe. And whether it's true or not won't have to matter, because at least I'll know your point. But I never know your guys' point. Saying the earth is flat, saying it's a conspiracy, saying this and that doesn't prove anything. I can say that, this being carbonated is a conspiracy and we've just been lied to our whole lives, but that doesn't mean that it's true. I mean, maybe, but probably not, right? So let's get into the questions real quick, okay? So I've written these down in a document, and I'm gonna pull it up right here, and we're just gonna, just kind of walk through it. I'm gonna kind of explain my points, show off some diagrams, because it's very important to visualize. You can't just say something sometimes. You have to show people, and that's not anything wrong with anybody. Round Earth, flat Earth, anyone, anything you believe, it needs to be visualized. You can't just imagine it. Like I could teach you how a car works, but that doesn't mean you know what it looks like unless you're a car person. So, without further ado, let's take a look at this document. So, here's our document. It's just questions for flat earthers by Cheddar780. Okay, and you can see here it's not too bad. It seems like a lot, but I'll kind of walk you through it, and we'll see what you guys think. Let's start off with the one that I always think of when I hear flat Earth. If the sun can see you, can't you see it? I'll explain this, okay? So, what I like to think of, if I were a flat earther, let's assume this is pretty flat. I understand there's the dip, but let's just, you know what I mean? Like Antarctica, right? Excuse me, flat Earth. So, what could we use as the sun? Because the sun is my issue here. Something relatively small. So, we'll use this eraser here. Right? Little mechanical eraser. Let's just say that's the sun, okay? Just for point of, I don't want to say argument, point of, like, showing what I'm talking about here. So, let's say this is the flat Earth, and this is directly north, right? Or at least this is above the North Pole, because you guys don't disagree that the North Pole's in the middle, and that the South Pole doesn't really exist, okay? So, the sun moves along the equator or so, okay? No matter, here's my issue. No matter where you put the sun, anywhere above this plate, okay? Anywhere above this plate, I can sit at the eraser spot and see all of the plate. What does that matter? Well, no matter what you believe in, okay, light goes out in all directions equally at c, the speed of light, which is about 300 million miles per second, I believe. I could be wrong on that. Might be meters per second. It still doesn't matter. The point is it goes out in all directions equally. So, if you put the sun here, its light can reach here, and here, and here, and here, and here. If you put it here, it can still reach here. If you put it here, it can still reach here, 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 here. And yet we know for a fact that half the time you can't see the sun, and half the time you can. So, how is it that you can have an area, let's say Australia, that is lit up, right? And America isn't. I live in America, so, I can tell you it exists. I'm an American. I don't know what you want me to say. But the sun can still see, so why can't we see the sun at night? You see, that's the question I have. That was the one that made me want to sort of make this video, is how does that work? I want to know why I can't see the sun when it's supposedly right above. And so the questions that I had involving that were, how far is the sun? It can be an average. It can be, okay, so we take, 50 points in the circular thing and we kind of average it out. Maybe the sun is off center, so like this would be further than this point. Okay, I understand, right? That would make sense if it was flat, okay? So on average, or from any given point, if I give you a point right here, you should be able to tell me how far it is. That's pretty easy, I'd say, right? You could do that. The sun is 93 million miles away in the heliocentric model, which is the round Earth. I guess the same would go for the moon, but you can see the moon during daytime sometimes. But the sun's more important here, because without the sun, well, it's nighttime, and when it's nighttime, there's no sun. Duh, right? And yet, on what I just showed you, there's no place where you can't see it. And there's no need to insult me over this. Just explain how that happens. Okay? How big is it? How big is the sun? Because this is very important, because distance and size, you guys don't get too descriptive with this, and I know why. Because if you get descriptive, we're going to math it out and figure out exactly what it'll look like from any given point. And that breaks down your argument, doesn't it? Listen, it's simple math and sort of, I don't want to say algebra, but like plugging in numbers, right? If you know something's distance, if you know its angle, okay, and you know how far it is, or how big it is, you can calculate a lot of things with that. And you can literally do light spectrums to tell you how far something is for the most part. And you know it'll disagree with what we've observed, okay? But you can try. I am fully willing to read every comment on this video and explain eclipses. This is a very general question, but explain how an eclipse works on your model. Okay, because at certain times the moon is here, right? The sun's never in between them, right? Never. But there's also the eclipse where the Earth's shadow is on the moon. Now, let's pretend that you are the sun. Okay, hello. And I don't know, this is the moon, and then this is the Earth. So, right, we can see the shadow of the disk on the moon, which presumed it'd have to be behind the moon. But we're on this side of the flat Earth, right? How can we see the moon at all? It can't be here, or else it's not going to get cast the shadow by this. You're not seeing the shadow of the plate on this. When I put it here, you can, but you can't look through the Earth. Like you might say, what if you're close to the horizon? Well, what about the infinite ice wall? You can't see through that, can you? Okay, so maybe we're like this, right? So that doesn't make sense either, because at least half the Earth is illuminated by the sun, which that would be none of it. See what I mean here? Maybe I'm thinking of it wrong. Maybe you guys have a great answer. Oh, it's this. And I'm like, oh, okay. I'd like to hear it. This isn't some sort of straw man type thing. This isn't some sort of disagreeing with your points. I'm just asking how things work, because you can observe one of those eclipses. Okay. Let's move on to the next one. I've seen this one discussed on YouTube a couple times. It is, why do you think the horizon appearing flat, due to your observation, your eyes, means that the Earth is a flat, round disc? So I have not only the plate, which is a bad example, I also have this Transformers animated disc. Very good TV show. We're going to set it like this. Okay? If I'm looking at it like this, for example, does the horizon, meaning the thing closest to my face, appear flat? Like this, right? Nope. Let's move it closer and further down, right? There is no point when it'll appear perfectly flat. It just can't. No matter how close you can get to a circle, it will not appear flat. But if it does, let's say there's a certain distance where it applies. Like, you know the distance, you know exactly the... Okay. At what point does the horizon appear flat, right? Based on the circumference, everything like that. What equations can be used to derive these answers? I want to see the exact equation. I want to see who came up with them, and I want to see all this data that I need, because I can't just be told you're straw manning. It's not how it works. How does it work with your distance from Antarctica, which is presumably the edge of the flat Earth? Okay, so most of the flat earthers agree that Antarctica doesn't exist in the way we think. I mean, if you are around Earth, you think Antarctica is this ice place at the bottom of the Earth. You know what I mean? Right here, and If you're a flat earther, it doesn't make any sense. So they say it's like stretched out as an ice wall. And why is it that you think the horizon appearing flat means the earth is flat? Because the horizon would appear flat. It's not. I'm telling you, it's not. You can do anything you want. You can't prove it's flat because it's not possible unless the earth is, I don't know, shaped like this. Are you saying the earth is shaped like this? This is the only way you can get a perfectly straight horizon. And if you look in the corner, oh, that horizon don't look like that, pal. It just doesn't. Okay? See that? It just can't look like that, or else there'd be these awful corners. And why haven't we observed any of the corners yet? Also, they say, well, I look over the water of, if I go to the south end of South America and I look over and I see no curve. You know what you also don't see? Antarctica. That's a bit of a heartbreaker because if it's just ocean and the earth is flat, you should presumably, despite diminished vision, should be able to see way far to Antarctica. You might say, no, we can't. Well, you can see the sun, which is presumably further than Antarctica. See what I'm saying? Why can't you see Antarctica from South America? Seriously, I'm not trying to. Nobody's getting insulted here. I'm not calling anyone stupid. I'm just giving you a chance to answer some of the questions I have. So, yeah, that's that. Okay, this one's always been confusing to me. Why keep it a secret? Okay? Let's say the earth is flat and we've been lied to. Okay? What does the government or the Illuminati stand to gain from it being a secret? Why would they do that? Why are there no real flat earth global agencies, on par with NASA? Everyone's like, it's NASA, they're lying to us. Yeah, NASA doesn't control everything to do with space. I know it's the only one you've ever heard of, but it doesn't, like, if NASA says something, that doesn't mean it's gospel. All right, it's not a religion. It's a space agency. They do space research, but that doesn't mean that they are just the final word, the ordained gospel speech of space. If a NASA employee went out and said, "I think a supernova will happen on this day," da 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 da, right? They would corroborate it. They would all test his theory. They would all test his numbers, and maybe he's right, maybe he's wrong. But just because he came from NASA doesn't mean that he's right or that he's lying either. That doesn't necessarily, because NASA people can be right about things. Come on now. And one of the things that I always wondered, if every scientist, you say that there's like no real scientist, every scientist is indoctrinated. When does this process happen, and how does it happen? Okay, because I did some light space research in high school. I did physics, and I'm always learning about space. And there are people I know that just went on to college and just continued their astrophysics degree, and quantum physics degrees, and Newtonian physics, and relativity. When do the man in black suits come up to you and say, "Hey, you've been learning a lot about science recently. You've been getting to the point where you might realize something. Here's a $10 million to shut the fuck up." That doesn't make much sense, does it? Because I heard of a flat earther that went to college for 4 years to study physics, and none of it ever made sense. But he passed, and now he realizes that the earth is flat. But he didn't get indoctrinated. So you can't say it's during college. So any sort of observation in college cannot be knocked out with the indoctrination theory. Because if they were doing indoctrinations, they'd be strict. They would not let them get a day by. Besides, how can half of physics be true but not the other half when they rely on each other? Like, how can one thing be true and not the other? That's like saying, oh, electric isn't a thing, but I need to charge my phone. What? If you need to charge your phone, electric's real. If electric isn't real, there's no such thing as charging your phone, okay? Is it when they first get their jobs, when they first get hired? Do the employers say, well, We're just going to pay you to sit around and lie all day. Welcome aboard. They're not politicians. They're scientists, physicists, right? Anything, any sort of mathematicians. Because you can do math and get the right numbers without saying anything about the Earth's shape. But then when you factor in the Earth's shape, they are corroborated and true. Okay? We can tell you exactly how long it's going to take this rock to fall to the ground based on the height and the constant and G, G and, 9.81, and it's also per second squared, by the way. You guys seem to mess that up. It's 9.81 meters per second squared because that's not a speed, it's an acceleration. Okay? When they say 9.81, that is not how fast things are moving. That is the acceleration of objects free falling towards the Earth's surface. I know that's tough, but there's an exponent there. It changes a lot of how things are thought about. Okay? It really does make a difference. I want to know about this, the indoctrination thing. That's always been a wonder for me, is how that works. So, go ahead, explain it to me. Okay, the next one is about the moon, and we've already gone over kind of the sun, but now we're going to talk about the moon, because that's the other, body that we see in the sky a lot, other than stars, which are a whole other issue I'm not even going to delve into today. So, Professor Dave delved into this one a little bit, and he says, why does the moon not change size and shape and appearance? So, size, okay? Got our planet, okay? Got our eraser, all right? If it's right directly over the North Pole, it has a size. We'll say 1. Just 1 measurement. That's the unit's name. It could be 1,000 meters, could be 1,000,000 meters. I don't know. It's 1 unit big, okay? Let's say it's over here. It's still 1 unit big, but looking at it from the other side of the planet. So maybe, I don't know, Australia and South America. I don't know if they're exactly apart. They're probably not, but just bear with me here. There's a bear with me here. 1 unit, okay? So there's something called angles, okay? There's a certain angle my finger has to lift up to line up with this eraser. And by doing that, we change the size of the object, okay? Because watch this. Ready? If you move it over far enough, right? Move it back, it changes its size. See that? Look how big it gets. Look at this. How do you explain that? How do you explain the fact that the moon does not do that? Not that we can observe, at least, okay? If the moon is a local moon and it's very close, then that also poses another issue. Why does it not change appearance? We'll get into shape in just a second. Appearance. Okay? We all see the same face of the moon. Sometimes it's flipped, sometimes it's not. Okay? That flip actually kind of ruins everything, because the flip cannot be explained by a round Earth. However, there is no point on the entire planet where you will see the other side. It's called a tidally locked body. Meaning, it goes like this and then it orbits like that. The Earth orbits like this. Okay? It's spinning and it's going around. The moon just goes like this. It does this. It kind of perturbs. Okay? But you're never going to see the dark side. That's why, Pink Floyd, Dark Side of the Moon, Transformers, Dark of the Moon. It's such a mystery because, you know what I mean? Because I dare you to produce a photo of the backside of the moon. I don't even think half of you could draw the backside of the moon. Do any of you actually know what the backside of the moon looks like without looking up a picture? You know what the front side looks like. You could take 2 photos and be like, that's the moon, that's not, that's, But the backside? No, you couldn't. That breaks down on a flat Earth. Because, 1 second. Can I mark this somehow? Alright, we have the side that points away from my hand. Okay? People in South America see that, but people in Australia see the bottom of my hand, right? See this part, this bottom part, right? They'd see different faces. And if we put it right in the middle, now it's a huge problem. Watch this. Now it's a huge problem. Watch, see? Because I see this face. Okay? Gentleman over here sees that. He sees this. He sees that. That's different faces, and it could rotate too. Do you think the moment someone looks up, it goes like this to fix the correct face? No, it doesn't. Okay? See, that doesn't really follow logic. And if the moon is directly above us, actually, let's think of it differently. Let's think of a frisbee, okay? Because a frisbee could be what the moon, it could be like a spotlight moon. Okay, so we clear up the same face issue briefly. What we don't clear up is the shape, okay? Because you're playing frisbee with your homeboys and you look up above your head and the frisbee looks like a spotlight, right? But then if you throw the frisbee away, right? Look at that. See, you move it above your head, it looks like a spotlight. You move it away, the spotlight's on someone else. And it looks like a flat thing to you. The moon has never been observed to look like a flat, awkward looking plane, kind of just, you know, it doesn't make any sense. I know the moon one's a bit gimpy and all over the place, but seriously, Professor Dave's got a great video on it. People like to go after him, but just answer my questions. Can you explain any of these with any kind of formulas? And if you use terms like electromagnetism or something with light scattering or, you know, gosh, I don't know. Why doesn't this happen with planes and birds? And what are some equations you could derive a prediction with degree of error? Because we can see planes change shape because they're so close to the surface. Planes only fly about 35,000 miles above the surface. The moon is like 30 Earth lengths away from us. Like you could fit like 29 Earths in between us and the moon. It's very far away. Way further than you think. And the planes are only like this far off the Earth's surface in the grand scheme of things. I know there's nothing to scale, but my point is, why don't birds have this happen too? Why don't why don't I see a bird's beak the entire time it's flying, no matter where it's going? Like it could go like this away from me. No, the bird turns around, flies away. How does that not happen with what happens to the moon? The next one, we just get into some weird stuff, so let's just do it. Alright, here it is. Gravity. Okay? Gravity. It falls, right? Stuff falls down. You could throw it, right? And guess what? Comes right back down to you. Thank you for that demonstration. Okay? You say gravity doesn't even exist. Now, here is what I've always heard round earthers try to explain. Because we like to try to explain things that don't actually exist. Why does this happen? The thing accelerating up at 9.81 meters per second would actually do it. It'll explain it. Yes, for real. If you take a flat earth and you accelerate it at 9.81 meters per second, that would indeed explain gravity. Everything else can just move alongside with it like it does in the heliocentric model, and boom, you've got yourself gravity. You guys don't need to fight gravity, and yet you do. The one thing that you can't explain with a flat earth, you guys choose to debate. You cannot just cite density and buoyancy, okay? It does not give things a reason to fall to our feet. Okay? Because I'm sure something in my head is more dense than something in my stomach. And something in my stomach is more dense than something in my feet. So why doesn't my body go like this? You know, resort itself. Okay? You might say, because there's pieces that are held together. By what? As we see down here, if gravity does not exist, how does the flat earth stay together and not have all of its matter break apart over years of erosion and things of that nature? What keeps this ground together? There's clearly, like, the Marianas Trench isn't deep compared to the heliocentric model. Compared to your flat earth, might be huge. I don't know how deep the flat earth model is, because you don't have one. But wouldn't you expect a non-gravity world to fall apart? What reason does this thing have to stay together? It's on. What reason does this thing have to stay together? Why is this matter here not just dispersing and falling to the ground? Why doesn't it turn into essentially a liquid and just fall apart like you would in like a black hole's, you know, event horizon? If dense objects want to move down and they pick one up, okay, this is the one that I always say. Can you derive a speed and expected arrival time for when it touches the ground with any formula without the gravitational constant, since you say it's faulty? I know, right? Or even just 9.81. If you guys don't like that number, don't use it. But you need to be able to make predictions. If you want us all to believe flat Earth, imagine if we all believe flat Earth. It'd become a conspiracy. Maybe the Earth is round. Okay? You're never going to get complete agreements. I don't understand why insulting people is how you get that anyways. So I stand on a 100-foot cliff. I drop a rock with a certain density, or, not accounting for air resistance, maybe a vacuum. Rock falls. Why can you not predict exactly when that rock is going to hit within a second? Within a second's a big margin. You might get it might be 6.2, but you might say 6.3, 6.9 seconds. I'd be like, well, you were within a second, so maybe it's not so hard. Let's do some interplanetary stuff, right? I need to see some formulas, and I need to see some math done for that, because I don't think you guys have a gravitational attraction formula. I've never heard of one for flat Earth. Now you might say, whoa, 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 there's no gravity. Okay, the falling equation, the density equations. Density, as all you guys say, is the matter in which your volume is taking up, right? So, like, how much matter there is in that volume. So I could take this Mountain Dew bottle, not very dense, but I fill it with stuff, and I crush it, and I fill it, and I put more matter in there. It'll get dense. So it'll get heavier, right? Gravity will affect it more. You can't just say it's more dense than the air, so it falls. That is kind of the truth, but why doesn't it go like this? Up. Why doesn't it go over? It's more dense than that air. Why doesn't it go through that? Why does it go towards the ground? See, if the Earth isn't accelerating up and gravity doesn't exist, why does it fall to my feet? Why is it feet favored over, hair favored or shoulder favored? Why doesn't it go diagonally or this way, right? It just doesn't make sense, does it? And we got a few more. We have this one next, and then we'll just get into the general questions, and we'll be done. And I'd really like to see what you guys think. Okay, and finally, we are on to number 7. Smaller questions. What is under the Earth, and what is the thickness of the Earth on that note? So, how far could one dig until they found something, whether that be empty space, or would you just keep digging? Another Earth on the opposite side of the disk, Like, we dig a hole through our flat Earth, and on the other side, there's another flat Earth. Because supposedly, the air here is less dense than something here, so it would fall back to the flat planet, which is you're just citing gravity. Saying that density causes things to fall is kind of true, but that's gravity. Like, density is a product of gravity existing. If gravity doesn't exist, density means nothing. It does nothing. It literally means nothing. Okay, because things want to be at a low energy state, and when things fall, mass collides, they're lowering their energy, their potential to kinetic, and then they're releasing it in collision, friction, heat energy. Okay? That's why when you go down a slide, you don't just kind of move out, you move down. Okay? Because space-time is curved, and matter curves it because it wants to be together. You could say, well, there's no reason for it. There doesn't need to be a reason. Okay? There's no reason we can only see the light rays that we see. There's a lot of light, ultraviolet, gamma ray, X-ray, that we can't see, microwave. There is a scientific explanation, but there's not a reason. There's not like there's a book somewhere that says, here's why you can't see those colors. Okay? How does a GPS work? Navigation is irrelevant. I'm not asking what it does. I know what a GPS does. But what communicates an active location symbol and finds the fastest way to a destination? If the Earth is flat, what are you communicating with? Because anyone who knows what a GPS does knows it communicates with satellites. On that note, how do phone calls work? How does anything Bluetooth-ish work? Anything that goes over whole countries with their signals and stuff. How do seasons work? How do the tides work? Coriolis effect. Explain time zones. They don't make sense to me on a flat Earth. And if round Earth is so incorrect, if you guys can't even begin to think about it, why not do some of the round Earth experiment yourself and see what happens? Not to prove anything, just to observe. Like covering your eyes and then trying food. You don't know what to expect, so there's no bias. And the last two things. Oh, okay. I'll explain that real quick. I'll explain that. So I could sit here all day and present evidence for both sides, more round earth than flat, obviously, but or I could just do all the experiments, okay? And in any experiment I've seen, any data I've seen, round earth makes way more sense than flat earth. And you might be sitting your head saying, scratching your head saying, what is Occam's razor? Well, in principle, for me, someone who's not, so philosophically inclined, it essentially says the simplest answer is the best answer. Okay, let's say you got a significant other and they haven't answered in a few hours. What are the reasons? They're sleeping, they're dead, they're cheating, they're doing this and that, right? They've gone on a trip and their phone just happened to die even though they charged it because they've dropped the battery out of it. Occam's razor says the simplest answer is that the person is sleeping, and guess what? About 99% of the time, they're sleeping. They're not out cheating, they're not dead, So the simplest answer is around Earth. Ask a kid, right? Any kid over the age of like 5 has realized that the Earth is round. Look at a globe. It's the school's agenda pushing it. What about people who dropped out of school and did independent sort of studies and have proved the Earth is round too? You think the school system's been the same all the way back to the ancient Romans or whatever? You think Cavendish took Common Core? And my last thing, why all the insults to people who ask you questions? I've asked you 40 questions or so. I didn't number them. I've asked you a lot of questions. I am not looking to fight with people. I just want to know what you guys think. If you give me an answer that I think is incorrect, I will tell you why I think it's incorrect. I will say, no, that's not how that works. You could say, well, this does this. I'm like, well, that's simply not true because we don't observe that, okay? But I'm not going to sit here and listen to you're such an idiot. You need to wake up. Open your eye. Like, that's not how you get someone to listen to you. That's how you get someone to dislike you and your entire community. So why all the insults? I am just looking for answers. So simply just proof of everything. Anything. Prove anything. I don't have any proof of any of this on a flat earth. None of it makes any sense. Now with that being said, I thank you all for watching. I know this is a bit of a different thing. I rarely ever just make videos, but I just wanted to say this. I just wanted to ask questions. I plan on doing a sort of, answering flat earthers questions. So I'm going to compile questions that they ask us, or any questions that I get on this video. Probably won't get many views, but let's say I do. I'll probably do anything answering your guys' questions. Yeah, if you find this video and you're still watching, thank you. I really appreciate it. Make sure you show everyone this video. Any flat earthers in your life, show them. Get their answers. Hit me up in the comments. Okay. Yeah, I mean, it's rough out there, Okay. Here is a huge point I have to make. This is less about the Earth and more about sort of the implications. Cherry picking and a flat Earth model. Before I say anything, why do you guys not have a dedicated model to explain observation? Seasons exist. You can't deny that it gets cold in the winter and hot in the summer. I'm going off New York, by the way. I'm from New York, so I'm going off what happens in New York. It gets really cold in the winter. It gets really hot in the summer. It's kind of in between. And why can't you explain eclipses? Why can't you explain, Coriolis effect, which I think is down there? Why can't you explain all these things that happen? We can prove that they happen, but your flat Earth model doesn't explain it. You need a model that explains everything at once. On the heliocentric model, works out just fine. It really does. Because what happens, okay? Well, it rains. You can't be like, maybe the government... No, the government doesn't give a fuck. It rained, man. So we have to explain why it rained. Well, the water cycle, evaporated and then gathered and then, cooled down and then fell back down to the ground and rained. That's kind of just, really simple water cycle there. So, if you believe all sciences and all scientists are wrong and government lies, then how do you suppose we built things like computers, cars, cameras, structures like buildings, and satellites? Cars run off gas, which burns, and a lot of engine and rotary pieces. But we use physics to, the tire pressure, how much weight it can hold, the suspension, how much impact. Cameras measuring light rays that bounce into lens and do this and that, and quality image increasing, AI upscaling. How does that happen if all sciences are wrong and all scientists do is lie? We can prove that cars go because cars move forward. It's not like your force of your leg on the pedals moving all of that all that weight forward. Because if that was the case, then a bike would be, the moment you touch a pedal, and it doesn't do that. You know, it just doesn't, and you can't be like, well, it does. No, it doesn't. Okay, we have to stop these like sort of imaginary maybe. No, we have to go by facts because we're talking about the shape of the planet that we are on right now. Okay? Is there no computer simulations of a flat Earth such as Universe Sandbox or Space Engine for heliocentric models? So for the heliocentric model, the globe Earth, we have the Universe Sandbox game, which I play a lot, sorry, and Space Engine, which I don't remember if it's a newer one, but you can explore the entire universe. I need to buy it. Why is there nothing like that for flat Earth? Presumably, there's at least one flat Earther out there that develops games, right? At least one. Why has there never been talk of a flat Earth universe sandbox? Oh yeah, because you guys don't have your own laws of physics and your own model, so you can't agree. You just can't. And once you do, maybe we'll start believing you a little bit more. But when you guys all argue amongst yourselves more than us, well, how can we believe you? It's like if let's say you were a parent and your kids wanted to get a cake at the store and you guys are about to leave and the kids were telling you why they wanted the cake. I want the cake because it tastes good. And the other one said, well, I want a cake because they like the color of the frosting. No, 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 right? She's not going to get them the cake. But if they both come to her and say, hey, I think the cake would be a really good investment on your kids right now, right? She'd be like, well, excuse me, you're agreeing, so I'll hear you out. But if they're disagreeing, why even listen to them? It's full of shit, right? Um, I know this video might seem a little like long paced and sort of slow, but I don't mean to rush through things. I really just want to hear what you guys think. I don't believe you guys have a model. I'd love to get one though, because I do want to study it just to see what you guys think. So all that being said, I hope you guys enjoyed. Just kind of weird making a video. It feels weird not streaming. I've done a couple takes for a few of these clips. Um, but if you guys enjoyed, please let me know. Please let me know what you liked about it, what I can improve about it. Don't know how the audio is gonna be. Don't know how the video is gonna be. I'm gonna run it through my editor and I like my editing software and go through everything and do what I can. It's like 7:30, right now for me on the 30th. So maybe this will be uploaded by tonight. Maybe this will be uploaded tomorrow. I really don't know, but either way, I hope you guys enjoyed. I am no physics major. I'm in college, but I'm not studying anything to do with this sort of stuff. But that doesn't mean I can't speak of it, because there's observations that I make that people can't explain. So I hope you guys enjoyed, and I'll see you guys later. Goodbye.